Not all quadratic equations are factorable or can be solved by using square roots. So for example, for this one here, we've got x squared plus 6x plus 2 equals 0. So we're fortunate there's no coefficient in front of the x squared, so if you're going to try to factor it, I'd put an x as the first piece inside of each set of parentheses. We then look to see that we're multiplying to make 2, but then we're adding to make a positive 6. So what I know then is if I'm multiplying to make a positive and adding to make a positive, I'm going to need two positives here. And then I've got to try to find a factor pair that multiplies to make 2 and adds to make 6. But this is where we right away see that we have a problem, because the only way I can multiply to make 2 is 1 times 2, and 1 plus 2 definitely doesn't equal 6. So that means this problem is not factorable. But we also can't solve using square roots because I have an x term in the problem. So I'm not going to be able to isolate the x squared and then be able to take the square root of both sides, because then I would still have an x over on the right hand side of the problem. So I'm going to have some alternative way of solving this question. My answers in this type of circumstance are going to involve some square roots. They're going to be complicated answers. They might even be imaginary or complex. But we still have to be able to find those answers, so we need some other techniques. And so the technique that we're going to go over here today is called completing the square. So what it means to complete the square is we're going to change this problem so that the left-hand side will be factorable, and then we'll be able to use square roots in order to finish off the problem and solve. So we're really kind of combining some factoring as well as some square roots in this technique. So the way we're going to do that to start off with is we're going to isolate the x pieces, the x squared and the x on one side of the equation, and then the number piece on the other. So I'm going to have x squared plus 6x, and so I'm going to subtract 2 from both sides, but then I'm going to leave a little gap here, and then I'm going to write 0 minus 2 is negative 2. And so I've got my equation rewritten with the x's on one side and then the non-x pieces on the other. And so now this is where the step called completing, where the name completing the square comes from. This is the step that does it. And so the way we come up with the number that we're going to add to both sides that's going to make it so that this left-hand side is factorable is by doing the following. So first of all, we know our coefficients are a is the coefficient in front of the x squared, b is the coefficient in front of the x, and then c is that integer piece. So our focus is on the b coefficient, the number that's in front of the x. So in this case, that's 6. And so what we're going to do is what it says right here. We're going to add half of that number squared to both sides of the problem, because that's going to make it so that that left-hand side is going to be factorable into a perfect square. So I'm going to take 6, I'm going to divide it by 2, and then I'm going to square it. So we know that 6 divided by 2 is 3. So what we have is 3 squared, so it's 9. 9 is the number that I'm going to add to both sides of this problem. And I, of course, have to add whatever I add to one side, I have to add to the other, so I have to add it to both sides. So on the right-hand side, it's not terribly exciting. It's just negative 2 plus 9 is 7. But what that does for us, by adding 9 and coming up with that number the way that we did, the left side is always going to factor into a perfect square. It's going to factor into the same thing in both sets of parentheses. It's going to be an x as the first piece. I can see it's going to be 2 positives because we're multiplying to make a positive, we're adding to make a positive, and it's always going to be half of b before you square it as the number that's going to go into each of these sets of parentheses. And so for this case, half of 6 is 3, so that's going to be what we're going to put here. It's going to be 3 in both sets of parentheses. Or the other way that we could write this then is x plus 3 squared instead of x plus 3 times x plus 3. So what we've done is we've turned this left-hand side into a perfect square. So at the beginning it wasn't factorable. This is the problem from the other slide. Couldn't break it up into 2 sets of parentheses, but by adding the number that we did and coming up with it the way that we did, we were able to turn that left side into something that would factor into a perfect square. And so now I can undo that square with a square root. And so I'm going to take the square root of both sides of this equation. So now I've turned it into a problem that I can solve using square roots. And so on this left-hand side, I've got the square root and the square are going to cancel each other out. So I'm just left with x plus 3. And now on this other side, I need a plus or minus, but I can't really do anything with that square root of 7. I can't factor tree that down. It's not imaginary, so I don't have to worry about that. So I just leave it as plus or minus the square root of 7. And so now we just have one last step that we need to take to get the x by itself. We've got to subtract 3 from both sides. And so I'm going to have x equals, and now I'm going to write it in that kind of format where I've got the negative 3 first, and then plus or minus the square root of 7. So we saw some answers that looked like this when we were solving via square roots, which is what we've eventually done after that completing the square step. So x equals negative 3 plus or minus the square root of 7. So for the second example, we're going to follow the exact same process. My first job, as it was before, was to isolate the x's on one side of the equation and throw the numbers on the other. Well, in this case, I'm fortunate, I already have that. But I am going to rewrite it with a gap here because now I have to come up with that number that I'm going to add to both sides that will complete the square, that will make it so that that left-hand side factors into a perfect square like it did here, so that I can use my square roots to eliminate the square and then eventually solve for x. So the way we're going to do that is take the number that's in front of the x, that's our b value, and so negative 14 is going to get divided by 2, and then we're going to square it. So negative 14 divided by 2 is negative 7. So then I've got to square negative 7. So negative 7 times negative 7 is going to be positive 49. So you're always going to end up adding a number to both sides. You'll never subtract something from both sides in this method. You're always going to end up adding a number. So in this case, it's plus 49 on both sides. Again, it's got to be both sides so that we keep things balanced. So now on the right-hand side, negative 19 plus 49, so we get 30. And then on the left-hand side, we're going to factor. This time, though, I'm just going to jump straight to writing it in this squared format, since I know that it's going to factor into a perfect square because of how I came up with this 49. And so it's going to be x, and then again, it's always half of the number in front of the x before you square it. So negative 14, half of that is negative 7. So that's what's going to go into the second spot in our parentheses. So now at this point, we've got x minus 7 squared equals 30. So we want to undo that square by taking the square root of both sides. We're now solving using square roots. So the square and the square root cancel each other out. So I've got x minus 7 equals, now I'm going to have plus or minus. And now if I try to factor tree 10 or 30, it's going to be 3 times 10. And then I get 5 and 2. So that's just not going to lead anywhere. I'm not going to be able to find any perfect squares inside of it or pairs of numbers. So it's just going to stay square root of 30. And so then our last step is to get x by itself. So just add 7 to both sides. And so we get x equals 7 plus or minus the square root of 30.